Parallel axis theorem is another important concept in mass moment of inertia. Okay, say that if you are, first let me go back to the tables. You see in the tables, for example 1, the mass moment of inertia, the I value, is given with respect to y and x axis. It's also given with respect to y prime and the x prime axis. Okay, then what it means is that you can give the I with respect to any axis. Okay, this axis, it can be, for example, ix, it can be iy, and then it can be iz. Say that this is the body. You can have the, let me look for a little bit different case. Okay, the rotation of this body, you can look for around this axis, how it rotates. You can look for around this axis, how it rotates, and then you can look for this way. It will be tough to draw it, but let me try my best. Okay, let's do it from beginning. So for this body, you can look for rotation around this axis, rotation around this axis, or rotation around this axis. You see, you have 3 different options to look for the mass moment of inertia calculations. But it's also possible that you look for with respect to a different axis. Then that's not x, y, or z. Okay, so that's what we use the parallel axis theorem. So the axis, say that this is our axis of rotation, and I will call this one as z-axis. Okay, say that iz is given as 1/2 m into r squared, and this is the r value. Okay, but let's assume that you are trying to find what is the iz prime. How can I find this iz prime? And then to find the iz prime, we use the parallel axis theorem that says that iz plus the axis that you know, mass into d squared. D is the distance between z and then z prime. Okay, and then here d is same as the radius. But it is possible that you look for with respect to this axis or that axis, any axis you look for, but you are doing this parallel axis theorem. But you have to notice that the axis should be parallel. That's what the name says, yes? The axis should be parallel. Okay, then we have an example that I will solve in the next record.